Well, hello, welcome to the recording for Java programming. You can see this is the OOP unit, and for this class it runs November 11th to the 15th, and this is week 4. And you can see in the OOP unit we have the week 4 write-up, we have class and objects quiz, constructors quiz, inheritance quiz, then casting quiz, abstraction interface polymorphism quiz, overloading overriding quiz. So lots of quizzes this week. There is one program, and you can skip that or you can do it. Some students are choosing to do it. Remember, with all the issues we're having with downloading the software and getting everything to work right, that I'm going to restructure this class, but I know some of you have preferred to do the program, so give that a shot. Well, let's go on down to the write-up. So here we are in the OOP unit, and OOP is object-oriented programming. And let's go to the write-up first. And what does OOP allow you to create? So that's in the introduction section. So OOP, so it's a technique, is a way of organizing programs that can be accomplished using like any programming language. And what it allows you to create are flexible modular programs, because you can create objects that are reusable. So OOP allows you to create flexible modular programs. And it talks more about that down here. Really, you create a blueprint of the object, then you reuse the blueprint. In this whole unit on OOP, we're going to look at class and object, how objects work, explain methods and variables, define and use static methods. You can see all the things that this is going to look at. Now, some of the assignments, remember, we're changing things up, so don't go by this, always go by the grade book. We'll help you with that. And lastly, here are some of the key words, some of the terminology that you'll be learning in this unit. Okay, back to the write-ups, we can go into section A. In section A, static fields or class variables refer to what? What happens if you do not assign a value to a final variable? So again, this unit we're talking about object-oriented programming, and we look at the basic elements of class and learn about how class of objects are used. And we've seen some of these things before. You have a class of objects and then it can be reused different, like this just shows how it can be used in 8 different instances. But that's the idea about object-oriented programming. And in this section A, we're going to understand classes, comprehend how to use objects, explain methods and variables, comprehend method overloading, define and use static models. So class variable, static variable. So previously we learned about classes in VB programming, but we just learned about the basic form of a class. Class was used to serve as a container for a variable which had just static information, meaning information doesn't change. But there is information that can be changed. So fields that have a static modifier are referred to as static or class variables. And let me go back to the write-up to remember what our question was. Static fields or class variables refer to what? So fields that have the static modifier are referred to as static fields or class variables. So fields that have the static modifier, that's the answer to that Class Connect write-up question. And class variables, they're referred to by the class name. So you can see in this example up here, the class name as bicycle dot number of bicycles is the class name. Or that's the class variable, I'm sorry, the class name is bicycle. But the variable that they're using is the number of bicycles. So the class method and static method, you can see the way the syntax is. And then look at the program below, and you can see the different methods that are used in this program. An instance variable. So a local variable which is declared within the class can be accessed by the instance of the class. So from the above model, result is a local private variable which is accessible in the model that's called class. So you can see there's the local variable. Of course, that's just a comment line just to tell us what the local variable is, which is the word result. Now, final variable, a variable can also be declared using the final keyword. Once a variable is declared with the final keyword, it should be assigned a value. Now, if a variable is not assigned, the program will not work. And I believe that was the Class Connect write-up question. What happens if you do not assign a value to a final variable? The program will not work. So if a variable holds a reference to an object, then the condition of the object may change depending on how the object is used, but the variable will always refer to the same object because it's final variable, meaning that it won't be changed. Classes and objects. Now looking at this code, so you can see the code that they've created here. When you enter this method, it will return an integer value by adding x and y. So we're telling it the keyword add, integer x and y, and then down here it's going to return the value of x plus y. When the same operation is performed using a void method, the code will be like this. So you can see how using the void method results in a little bit longer coding. Here's a practice activity, so you're welcome to go through that. Now here's what they've started to do in last unit and this one. They give you a program to do, but then they show you a place where you can input the code. Now I want to show you something that could be interesting to some of you who are really into the coding. I'm going to go down here and show you a website. That wasn't what I wanted. Let's see, where did that go? Right here, this website. It's called learnjavaonline.org. And look at this. They have a box over here where you put in information. You put in all the coding. So you can just copy and paste coding into here. You could change coding up. So I could like put Ron H world. You run it, and it executes over in this window. So this is the way you can test to see if your programs run the right way. Isn't that cool? So what you can do in the course, you can take some of the sample programs they have and you can just paste them right in here. I'm just going to delete just to show how you can get rid of stuff in here. Just paste the code right in there, hit run, and then you can see how that code works. So those of you that want to really do this coding, go ahead and take a look at that. And I might just choose some of the examples that we see in the course and suggest that you go do that. So again, this is area of a rectangle program, so they have you try to figure it out, and you could click right there to reveal the answer. And you could take the copy of that code and go put it in that page that I just showed you. So final method is used for two reasons, for performance and design. Performance means the program will run more quickly. With excess coding won't slow it down, and the design just streamlines the output of the program. Classes and objects, so again they're talking about final classes. So if a class is declared with the final word, then all the methods by default are final methods. So that kind of streamlines, so you can't override things once you declare that final method on them. There's a Java app object tutorial, so go through that to learn a little bit more about Java objects. Practice activity, a drag and drop. And then the class and objects quiz. And as always, quiz previews. I have the quiz previews for all the quizzes in this unit are all in one document right here. So I'm sure you'll do well on the quiz. Okay, let's go back to the write-up. We need to go to section C. What are constructors? What are constructors mainly used for? So section C. So now we're looking at section B, I'm sorry. back to that write-up. Okay, section B, what are constructors? What are constructors used for? So section B. All right, in section B, constructor is a basic part. That's not what a constructor is, but a constructor is a method with the same name as its class. That's what a constructor is. And we're going to understand constructors, classify constructors, comprehend the methods of constructors, understand the principles of constructors. So the real answer, so constructors are a special method that can be used to create and initialize an object. So that's what a constructor is used for. Let me go back to that write-up. And so we said, what is a constructor? What are they mainly used for? And that's what we just talked about. Characteristics, the class name and constructor name should be the same. Constructors are called only once when an object is created. The return type of a constructor is void, since it will not return any value. Benefits of constructors. And actually, here's the answer to what they're used for. They're mainly used to initialize variables with a class. And I think that's the answer we had before, too. So to initialize the variables in a class. When you use constructors, you can specify the codes that are needed for initializing the variable. So if you look at this code, this doesn't have any constructor in it. Therefore, after creating the object, you need to set the default age for the student. So right here, you can see where they're setting the default age for the student. So you have to do a couple of different things. But if you use a constructor, like down here, you can see the constructor is student, and then they can, and then you can give the variable the age. Now, there's no definition of constructor. Look at a sample program to clarify how they are used. So we go ahead from the above program, what is the class name? So if we slide up, you see the class name is cube1. And how many constructors do you see? Well, the constructor, or cube1, and then the cube1, the integer. So that's the full name. So those are the constructors. So you can see that what they're doing is they don't have to, they're reusable. So it just makes life much easier. Here's a practice activity on constructors, a triangle constructor program. And again, if you want to, you can look at this code. I won't reveal it, but you can look at the code, and I think you can copy that and put it into that web page I showed you to see how it runs. Okay, constructors quiz, so that's right over there for you. Let's go back to the write-up. Now we're into section C. There's three main types of inheritance. So section C. So inheritance is a cornerstone of OOP because it allows creation of hierarchical classifications, which means that that different levels can borrow from previous objects and things that you create. So it's almost like genetics, isn't it? So we're going to look at understanding the meaning of inheritance, comprehend the working of inheritance, explain the types of inheritance, understand the this keyword and the super keyword. Here's a tutorial on inheritance, so you can start and run through that, and it'll talk about the different factors of inheritance, the thing you need to know about inheritance. I'll just go ahead and open up the text version, because I think I will open this up. Doesn't look like it wants to do that. Oh, well, there it goes. There we go. So, there's the script, and this is going to talk, all about inheritance. So, you just, want to read that, and it really talks about inheritance of, as an example down here, of genes and things like that, but you'll learn a little bit about inheritance there and how it's kind of in programming. So three types are single, multi-level, and hierarchical. So single, of course, is just the properties are passed straight down. So So the base class and then your derived class. So the derived class would have the same information as the base class, be completely inherited. So if you look at this, the mountain bike is inherited from the class bicycle. So mountain bike extends from bicycle, essentially, is what that means. So mountain bike will have the same criteria as bicycle. Now here's a coding activity. You can give that a try. Multi-level means that inheritance is passed down a couple of different levels, obviously. So you can see there's class A, then class B inherits from class A, class C inherits from class B. Here's a multi-level inheritance program challenge. So you can take a look at the code, and you can again copy that code and put it into that web page that I showed you a minute ago. Now hierarchical, you can see, is different, where this would allow inheritance to a number of items simultaneously. So you can see the bicycle is being extended into monocycle, tricycle. So it's doing two different things rather than like a straight flow through. So here's a class inheritance activity. You can give that a try. Discussion, of course, we're not doing any discussions in this class. The keyword this. The this keyword can be used inside any method to refer to current objects available in the memory. This always references the object on which the method is invoked. So you can see where they have this in the program here. I don't see where they have the word. Right here. I'm sorry. So this takes value that is assigned in the program. So the dimensions of the box are made available to the computer and for printing using the keyword this, useful because you can use it to assign values without creating an instance for the class. Here's a Java program activity with the this command. You can give it a try. And the keyword super. So you can invoke the overriding method through the use of the keyword super. So in the above program, the super keyword is used in the derived class to invoke a method in the base class. If you have a method in a derived class that overrides a method in a base class, you can invoke the overridden method through the use of the keyword super. So as we look up at this, okay, this is super class, and that's not where the keyword is being used, but keyword is being used down here, super print method. So inheritance practice activity, you can go through that. And then the class inheritance quiz. So quiz is right there, quiz previews up there. All right, 2 more sections, so hang in there. Section D, actually 3 more, I guess. Section D, difference between implicit and explicit casting. So section D. So casting is a mechanism for converting the value of an object into another type. Like casting makes a copy of something and would not affect the original. So we're going to cast a Java applet, explain casting types, use instances of operators. And here's an overview of casting, so you can listen to the avatar talk, or you can also look at the script where it talks about different types of casting and what you need to know about casting. So listen to that script, and you might it might help you a little bit with understanding a little bit more about casting, where they talk about implicit casting and explicit casting. So different types, so implicit and explicit, so those are the 2 types. So implicit means secret or not seen. So implicit casting is casting understood by the compiler but not written out in the code. So this one is where as it says, it's going to be hidden, and it's automatically handled by the compiler. So since the types are, so let's see, consider the superclass bicycle with a subclass mountain bike. There's bicycle, subclass mountain bike. Let B be variable for type of bicycle and M the type of mountain bike. Since the types are changeable, the Java compiler automatically handles the assignment. So it automatically does the work, implicit casting, rather than you having to put it actually in the coding. Explicit casting converts one type of data to another explicit, but explicit is actually done within the coding. So you could actually see how the casting is done. So for the above example, you're converting an integer data type to short data type because integer holds 4 bytes. But here the value of A is less than that. So you have to cast it to a new variable. So that's what they're doing with the coding down here. Practice activity for casting, so just a simple drag and drop. Instance of. The instance of operator, it compares. So compare one instance of something to something else. And if operation returns true, so it's like those true false operators that we've talked about before. So here vehicle is the parent class, heavy vehicle is the derived class. Heavy vehicle can be classified in many different ways. So as you look at this, you can see the different, so in the main class, you can see the objects created using base class HV, T, and HV2. So there's T, HV, there's HV2. And of course those were part of all the coding, and then down below, then those end up being the codes that's used to get your output. A program, a casting program, we're skipping that program unless you want to give it a shot. And the casting quiz, so right over here is the casting quiz, and the quiz preview's up there. Okay, the week 4 write-up, let's get back to that. 2 more sections. Give an example of abstraction. What is polymorphism in programming? So section E. So previous section we learned about object-oriented programming's 4 pillars. We learned about inheritance and encapsulation. But now we're going to learn about abstraction and polymorphism. So we're going to comprehend abstraction, learn and implement polymorphism, comprehend interface. So abstraction is hiding some non-essential information, showing just the parts of it or in the output of the program. And here's an example. If you ever have many workers were involved in building your house, well, that's not a good example for programming, though, is it? But it talks about, you might have a bunch of people build your house, but you don't really know who those people are. You don't have to know who those people are, right? But right down here, actually in programming, you might use the abstracting method when you want to use the method in the later parts of the program. So if you're writing a program to draw a rectangle, you can declare earlier in the program that you may need to draw a rectangle, but then later on you'd use the actual code to do it. So the one thing I'm confused about in this course, I'm really kind of disappointed, they talk about this rectangle as an example and then give us an example of some class with animals or something. So it really doesn't make sense. They don't show us what the example was that they showed, that they mentioned. So which class would be abstract up here? Well, abstract void dog, abstract void elephant. So the class that would be abstract is right here, animal, because so what they did, they set this up, then they might use it later on in the program. And how do we know? Because it has the word abstract in front of it. So interface is group of variables and method declarations. The variables in interface should have constant values. So this just talks about interfaces and the importance of those. You can see the syntax in interfaces. Examples of interface. So shape 2D is the interface name in which get the area method is declared. So shape 2D is the interface name. So you can always, a lot of these things you can just determine by looking at the item up here. We've had class up here, we've had interface up here. And a lot of times you can answer those questions just from that. Abstract class versus interface. Let's go ahead and, really don't need to worry about doing this. You can give it a try if you want to. Polymorphism. And I think we had a write-up question on polymorphism, right? Example of extraction. What is polymorphism? Okay. So this example, they're saying that the word speak can have many different forms, right? A dog, a cat, a duck, they can all speak differently. So that's an example of polymorphism, but not an example of polymorphism in programming, is it? So polymorphism, as you can see, is a fundamental principle of object-oriented programming. And what polymorphism allows is one method to behave different ways depending on different factors. It can be done with overriding and overloading. So what did I say? Give an example, or how is it used? What is polymorphism? Oh, okay. So what is polymorphism? So we just talked about that. Polymorphism is a feature that allows one method to behave in different ways depending on various factors. That's what polymorphism is. Okay, the abstraction interface polymorphism quiz. So we want to do that. And now we'll go back to the write-up for the last section, section F. What does overriding allow a programmer to do? So section F, pretty quick little section here, I think. So section F, in computer science, two methods with the same name that accept different arguments are said to be overloaded. Overloading is polymorphism. So we're going to implement the overloading method and implement the overriding method. So overloading, so this just talked about polymorphism again here, but overloading is where you declare multiple methods within the same class. So that's what overloading is. An advantage of overloading is that when the method is invoked, depending on the number of arguments, an appropriate version of the method is executed. So that's an example of overloading. And there's method overload, and method overloading is when the same method repeats more than once during the programming process. So if we look through this, the same method, which is myTest, is used in different parameters. So we have myTest right here, myTest right here. So that would be overloading. Then method override. So a method override, what that does is creating a method in a subclass that has the same signature as the method in the superclass. And what it does is it hides the method of the superclass. So that's what overriding allows you to do. And when we flip down at the bottom, the answer to the Class Connect write-up is that overriding allows a programmer to inherit from a parent class. Or if I want to use some of the features but not all of the features. So it's sort of like inheritance, but that's what overriding allows one to do. Principles, working principles of method overriding. So, just a couple of things to keep in mind if you are doing the programming part. Just keep in mind these two different things about overriding. Practice activity, practice program. You can give that a shot. Overloading quiz. Make sure you do that. And then the unit exam. We're not doing this unit exam because they have you write programs with all of these different methods in it, and I just don't think the course provides enough direction on how to do that. So this course will be changed up next week, as I have said a few times. So get back to the course home, week 4. So of course we have the work to do here, the quizzes that you'll do, and those of you that want to do the programs, feel free to do the programs. And next week you'll see that this course is changed up. You'll probably be doing some more research on programming as opposed to doing actual programming, but it will be based on Java programming. So you'll learn about Java programming through doing some research. So thanks, everybody. Thanks for maintaining your patience, probably a little bit better than I have. I look forward to your work coming in. Bye.